You know how to run a Docker container, but what happens after that? How do you see which containers are running? How do you find stopped containers? How do you see Docker images? How do you enter a running container? And most importantly, how do you debug it when something goes wrong? In this video, we are going to learn the Docker commands you will actually use again and again as a developer. And stay until the end because I'll show you a simple command flow that you can use whenever you are working with Docker. We are going to divide the commands into three groups. First, commands for Docker images. Second, commands for containers. And third, commands that are extremely useful when debugging. Before learning the commands, remember this distinction. An image is the packaged template. A container is a running or created instance of that image. For example, Nginx latest is an image. When we run that image, Docker creates a container from it. Let's start with Docker pull. This command downloads an image from a container registry into our local machine. Here we are downloading the Nginx image. Docker will look for Nginx latest by default if we don't specify a tag. Here is an important point beginners often misunderstand. Docker pull downloads the image. It does not start a container. So after pulling an image, we still need something like Docker run to create and start a container. Now, how do we know which images are currently available on our machine? We use Docker images. It gives us the repository, tag, image ID, creation time, and size. An image name can also have a tag. Here, Nginx is the image name and latest is the tag. Tags are important because the same image repository can contain multiple versions. Example Docker pull Nginx 1.27 and Docker pull Nginx 1.26. This allows us to explicitly choose the version we need instead of blindly relying on latest. We have already used Docker run, but now let's understand the command properly. Docker run creates and start a container. -d runs it in detached mode. --name web gives the container a predictable name. -p8080:80 maps port 8080 on our machine to port 80 inside the container, and Nginx tells Docker which image to use. Now we have a running container. How do we see it? Docker PS. This shows the containers that we are running currently in our system. This is one of the most useful beginner distinctions. Docker PS shows running containers. Docker PS-A shows all containers including stopped ones. So if you can't find a container using Docker PS, don't immediately assume it disappeared. Run Docker PS-A. If we want to stop the Nginx container, we can use Docker stop followed by the container name or container ID. Notice something important, stopping a container does not delete it. It simply stops the running process. This distinction is extremely important. Docker stop changes the container from running to stopped. The container still exists. To remove it, we use Docker rm. Now suppose we stopped the container, but we want to use the same container again. We don't need to create another one. We can use Docker start web. This starts an existing stopped container. Important to remember, Docker run creates plus start a container. Docker start the existing container. When we no longer need the container, we can remove it using Docker rm. But remember, normally the container needs to be stopped before removing it. Here is another common beginner mistake. Nginx is the image name. Web is the container name we assigned. They don't have to be the same. In fact, giving containers meaningful names is a good habit because it makes commands much easier to remember. Now we come to one of the most important debugging commands, Docker logs. If your application starts and immediately crashes or you don't know what is happening inside your container, check the logs first. The logs often tell you exactly what went wrong. Imagine we are running a Spring Boot application inside Docker. We run docker ps-a and discover that our container exited with status 1. Instead of randomly restarting it again and again, we check the logs. And the logs tells us the application couldn't connect to the database. That's the kind of debugging workflow you should develop. Now let's say we want to actually enter our running container. That's where Docker exec comes in. -I keeps the session interactive, -T gives us a terminal, and sh starts a shell inside the container. Now we are actually inside the container. Another misconception, Docker exec doesn't create another container. It executes a command inside an already running container. That's why the container needs to be running for this command to work. Docker inspect gives us detailed low-level information about Docker objects. You can inspect containers, images, networks, and more. It is particularly useful when something isn't behaving as expected and you need configuration details. We have talked about removing containers, but what about images? For that, we use Docker RMI. And remember, deleting a container and deleting an image are two different operations. Here is an error you may encounter. Docker may refuse to remove an image if a container is still using it. So first understand the relationship. Image, using image, we create a container. You may need to remove the container before removing the image. Let's connect everything we have learned. We pull the image, we verify our local images, we create and start a container, we check running containers, we inspect logs. If necessary, we execute commands inside it. Then we can stop it, start it again, and eventually remove it. Before we finish, try answering these questions yourself. If you are preparing for Docker interviews, don't just memorize the commands. You should be able to explain what each command actually does and when you would use it. These mistakes are extremely common when you are starting with Docker, and understanding them is much more valuable than simply memorizing a list of commands. And here is the flow I want you to remember. Something isn't working, first check docker ps-a. Is the container running? If it's running, check logs and inspect the container. If it isn't running, check its status in logs. Don't randomly try commands. Follow our debugging process. You don't need to memorize all of these in one day. The most important thing is to understand that what each command is responsible for. With practice, you'll naturally remember the commands you use frequently. In next video, we are going one level deeper. We are going to understand Docker images properly. We will create an image ourselves using a Docker file, understand Docker build, tags, image layers, and eventually push our image to a registry. So if you want to learn Docker step by step, subscribe to Code with Nima and continue with the series. I'll see you in the next video. Thank you for watching.